This is a continuation of section 8.5. This is basically a practice problems video. So hit pause, write all these down, try to expand them, and then I'm going to work through the solutions of each individual one. Okay, in this case, we're going to use the product property. Oh, need my pen. So we have log 3, 9 plus log 3x. Take a quick review, see if there's anything else you can do to it. You're done. Moving on. Okay, we couldn't do the power. There was no power. We couldn't use quotient because there was no quotient and no negative sign. So next one, expand. First thing we're going to do is power property. So then I have 4 times, oh I'm sorry, we're going to do the product property first. And where's my eraser? There it is. Product property first. So we have log 3 plus log x to the 4th. Now remember I didn't write the 10 because it's implied. This is the common logarithm. So then I have log 3 plus 4, because now I'm using the power property, log x. Alright? Okay, next one is simply, looks like power property. So I have 5 log 6x. Now, it's kind of a curveball. There's nothing different. The same rules apply to the natural logarithm as they do the common logarithm. So there's no powers, there's no quotients, so I'm just going to use the product property. So I have the natural log of 15 plus the natural log of x. Okay, this one I'm going to do product and then power. So there's no quotient. Log 749. I actually know the answer to that one. Plus log 7x squared. And so the ones that are completely obvious, highly recommend you go through and go ahead and do that exercise. So that's going to be log 749 is of course 2 plus log 7x squared, and then I'm not done, and so then I have 2 plus 2 times log 7x. And there's really nothing else you can do. You can factor out that 2, but then it's just 2 times 1 plus, and so you're really as simple as you can get. This one's a little harder because you have to do the power property first. Okay, this one's a little trickier. I'm going to actually just rewrite it first so you can see it. Same thing as what I just had, but I know what the square root of 9 is, so I'm going to rewrite again. So then I have log 3x to the 1/2 power, and now you can employ the product property. So I'll try to condense a little bit since I wrote over here. I should have gone up. Log 3 plus log x to the 1/2, which is equal to log 3 plus 1/2 log x, and that's the final answer. This one, we're going to do product first, so we have ln x to the 1/3 plus the natural log of y, y to the 4th. Now I'm going to use the power property, so I have 1/3 natural log of x plus 4 times the natural log of y. Last one, same thing, we're going to do product property first, so I have log x squared plus log y cubed plus log z to the 4th. Now I'm going to employ the power property. 2 log x plus 3 log y plus 4 log z. Okay, so if you ever struggling with this, come back to this part of the video. Next one is condense the expression. I didn't do as many of these because they take up so much room, but hit pause, write these down, try to work them out on your own, and then come back. Okay, so let's see if we have any power first. No. Let's do product next. That's anywhere around that plus sign. So this is going to be log 4, 7 times 10, which of course is 70, minus log 4, 2. Now I have that minus sign, so now I can do quotient. So it's log 4, 70 divided by 2 which is equal to log 435. And that's the answer for that one. On this one, everything has a power, so I have natural log of x to the 4th plus the natural log of y to the 6th plus the natural log of z to the 3rd. Now since they're all pluses, you can just go ahead and combine them all. So I have natural log of x to the 9th, y to the 6th, z to the 3rd. And that's the final answer for that one. Here, same deal. We go through, we have a bunch of powers to deal with, so we'll do log 4 3 to the 5th plus log 4 x to the 6th plus log 4 y to the 7th, and then they're all positive, so I can just put them all together. I'm not going to figure out 3 to the 5th, I'll let you do that. 3 to the 5th times x to the 6th times y to the 7th, and then now that expression is condensed. Okay, it's just the opposite of expansion is the condensing, sorry, of these expressions. Okay, sorry that got cut off a little bit. Use a property of logarithms to evaluate the expression. And what they're saying is that you know these logs. So I'm going to use the product property so you can see what I'm talking about here. Well, hold on. Hit pause, write them all down, try to figure them out, and then come back. So I have log 2, 4 plus log 2, 8. Okay. You know the answer to this, because if I say log 2, 4 equals x, to the x equals 4, x is 2. So this one is 2. For this one, log 2, 8 equals x, to the x equals 8, 2 to the 3rd power. So this one is 3. 2 plus 3 equals 5. That is the answer to that one. Okay, this one's a little sneakier. First I'm going to use my power property. So I have 3 times the natural log of e. Now I'm going to rewrite this as 3 times log e. Okay, now I'm going to do to this what I just did to that, which is log e equals x. E to the x equals e. Well, then x has to be 1, so this is 3 times 1 equals 3, and that is the answer to that one. Alright, log 2 8 squared. Let's do our power property. 2 log 2 8. So let's check this guy right here. 2 to the x equals 8, which is 3. 2 times 3 equals 6. Alright, quotient property first. Log 1 minus log 100. Remember, these are the common logarithms, so there is a 10 implied here. So I'm going to rewrite this. 10 to the x equals 1. Okay? So that tells you that this one must be 0, right? Anything to the 0 power is 1. So this is going to be 0, and then this guy is going to be 10 to the x equals 100. So that's 2. So 0 minus 2, so this one is negative 2. Okay? This one, natural log of 1 minus the natural log of e to the 5th. Okay? So on this one, now I want to do that power property. Since I did quotient first, I don't have a product property to do. So now I have natural log of 1 minus 5 times the natural log of e. So on this one, remember it's log e1 equals x, e to the x equals 1. So this one has to be 0, minus 5 times something. So in this one I have the natural log, or log e, which is the same one I did up here. So e to the x equals e, so that means x is 1, and so this one is equal to negative 5. Okay, Come to class prepared to work a lot of problems.